Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. A fun, challenging problem on probability. The problem states that 8 players A1, A2 through A8 play a knockout tennis tournament. They are divided into 4 pairs at random. 2 in each pair play each other in the first round, and the losing player is eliminated from the tournament. Assuming all players are of equal strength and no match ends in tie, what is the probability that exactly one of the 2 players, A1, A2, are eliminated in the first round? We start the problem by noting that if A1 is paired with A2 to begin with, then exactly one of them will be automatically eliminated after the first round, because one of them is going to win, the other one is going to lose, and since no match ends in a tie, that itself guarantees, the pairing of A1 with A2 itself guarantees that one of them will be eliminated. So we consider 2 cases. The first case is a simple one. So 2 cases of elimination. The case 1 elimination, the simple one, is that A1, A2 are paired in the first round. And this is a simple one because the pairing itself, takes care of the fact that one of them, or exactly one of them, will be eliminated in the first round. The second case is case 2 elimination, which is a little bit more involved, and this includes the possibility when A1 and A2 are not paired in the first round. So let's tackle case 1 first because it's the simplest case. But before that, we need to find out what is the probability that A1 and A2 may be chosen as a pair. Well, if you consider the number of possible pairs that A1 can be in, well, A1 can be paired with A2 or A3 or A4 or all the way through A8, right? And if you count the number of possible pairs where A1 can be, there are 7 possible pairs. And only in 1 out of these 7 pairs is A1 paired with A2. So the probability of A1, A2 being paired is simply 1 upon 7. Now let's consider the more difficult case when A1 and A2 are not paired in the first round. What is the probability that exactly one of them is eliminated? For this, we'll start with the probability of A1, A2 not paired. And this is simply the complement of the probability of them being paired. So we calculated that probability as 1 by 7. So the probability of A1, A2 not paired will be simply 1 minus 1 by 7, which comes to 6 by 7. Now, elimination of exactly one of A1 and A2 will occur if one of the following takes place, right? So A1 wins and A2 loses. So means that A1, whichever game he was in, he wins that game. He's not playing A2 because A1 and A2 are not paired, remember. And A2, whatever game A2 was playing, loses. So exactly one of them is eliminated. And in this case, A2 is eliminated. The other possibility would be A1 loses and A2 wins. So we'll now consider the probability of these events individually. So what's the probability of A1 wins and A2 loses. So this probability is simply going to be half multiplied by half, because the players are of equal strength. So each one has got equal chance of winning against each other. So the probability of winning is half, and that makes the probability of losing also half. So probability of each player winning or losing a particular game, both will be equal to half. So the probability of A1 wins and A2 losing is half multiplied by half, which comes to 1/4. And similarly, the probability of A1 losing and A2 winning comes to half multiplied by half, which is 1/4. So if we combine these two, so we just add them up, we'll basically get the combined probability of A1 winning and A2 losing, or A1 losing and A2 winning, as 1/4 plus 1/4, so that comes as half. And one of the things that may be helpful to decide whether probabilities will be added or whether they will be multiplied is basically noting the expression OR. So whenever there is an OR, then usually the probabilities will be added. Wherever there, in the other case, whenever there is a AND, the probabilities will get multiplied. So in this case, there is an OR, so the probabilities get added. And now for calculating the probability of elimination of exactly one of them in case 2, when A1 and A2 are not paired, we have to basically multiply 6 by 7 with half, and then we get this probability as 3 by 7. And again, here multiplication occurs because remember the AND. So we have the probability of A1 and A2 not paired being 6 by 7, and then there's an AND. So that has to happen, and one of the following, the A1 winning and A2 losing, or A1 losing and A2 winning has to happen. So that's why there's a multiplication. So these two probabilities get multiplied, and then the probability for case 2 elimination of exactly one of A1 and A2 comes to 3 by 7. And the total probability can be now found out by simply summing up the probabilities from the two cases of elimination, and that comes to 4 by 7. So the correct choice in this case is option D, 4 by 7.